In this last module, we will take a look at an example of an experiment with a single factor, and it's a very simple example. The whole topic of experimental design is a fairly lengthy topic, and we can have an entire course on the design of experiments. In fact, a number of these statistics courses do exist on design of experiments. But I would only like to at least introduce you to the concept. So let's take a look at a very simple example. So let's say that we have a certain part whose critical dimension we want to control, and we have been maintaining the X bar and the R control charts for this particular critical dimension for 6 months. Recently some tools were replaced and some changes were observed in the averages for this particular part, and it was suspected that it was due to clamp pressure, because that was something that we had not considered earlier. And so we decided to, it was decided, let's say, to test the effect of clamp pressure on the variation in the dimension. Okay, and the current clamp pressure that is being used is, let's say, 30 pounds, and we want to test the dimension, the critical dimension, at 3 other clamp pressures, and these are 20 pounds, 40 pounds and 80 pounds, and each of these would be tested for 1 day. So you test, let's say, at 30 pounds for 1 day, 20 pounds for 1 day, 40 pounds for 1 day and 80 pounds for 1 day. And so the control chart for 4 days of experimentation are shown over here. Okay, so what you see over here are day number 1, and this is for the same pressure, which is 30. That means this is when we have not made any change. Then we go about making 3 changes on 3 subsequent days. So that's day 2, day 3, day 4. Day 2 the pressure is increased to 80, day 3 the pressure is down to 20, and on day 4 the pressure is at 40 pounds, obviously. And the sequence in which we would change these pressures would also be determined randomly. Now let's take a look. You have the X bar chart, which is the one up here, and the R chart, which is the one down here. So if we were to first take a look at the X bar chart, what you will see is that if you observe, the X bar values do not significantly change. The X bar is pretty much stable. Okay, you don't seem to see any major effect of the pressure on the average or the X bar values. I shouldn't say the average, but the X bar values. However, when we take a look at the range, you see something interesting. The range value for 30, as you see, is sort of relatively stable. However, when the pressure is increased to 80, what you start to see is that all 8 of these points, now these are since it is done on 1 day, and there are 8 data points, maybe once an hour if it's a single shift. So you got 8 data points, and all data points fall below the center line of the R chart. So it obviously tells you that something has happened to the range of this particular dimension as a result of the pressure. Similarly, when you take a look at on day number 3, and the pressure is 20, now the number 1, most of the points seem to be in the region that is above the center line, and you also have 1 point that is out of control. Okay, and so this would tend to indicate that obviously the clamp pressure does seem to have an effect. And again, when you take a look at the day 4, where the pressure was 40, what you see is that the actual average range is below that of the when the clamp pressure was 30, and if we were to calculate now the average of the range values for clamp pressure of 30, compare it with the average of the range values when the clamp pressure is 80, compare it to the average of the range values when the clamp pressure is 20, and do the same thing for when the clamp pressure is 40, you will see something interesting. Well, first let's take a quick look at the description of the control charts. First, on day number 1, both X bar and R charts are in control. On day 2, the X bar chart is still in control, but the R chart, all the points are below the center line and no other causes are noted. That means that the reduction in the variation is likely due to increased clamp pressure. When you make the pressure 20 pounds on day 3, the variation seems to have increased with 1 point out of control, again likely due to reduction in pressure. And on day 4, both charts seem to be in control, but there's a slight decrease in variation, something which we had already discussed. So now if we were to take a look at the pressure and how it is varying on each one of those 4 days, if we list it in order of reduced average range, when the pressure was 20 on day number 3, let's say the average range, which means the average of these data points, okay, the values for the average or the range is given as 0, 10 and 23. So this average, which will come out to be somewhere over here, let's say comes out to be 16, it's been calculated. The average on day number 1 when the pressure was 30 was 10. On day number 4 when the pressure was 40 is 8, and on day number 2 when the pressure was 80 it is 5. From this, and if we were to plot the average range versus pressure, okay, so if you got pressure over here and the range over here, average range, what you'll see is a curve that looks like this, and there seems to be reasonable evidence to suggest that the clamp pressure has an effect on the range of this particular dimension. So what we would like to do perhaps is to keep the we would like to make the clamp pressure 80 and then monitor the situation for some time to see whether or not this is sustained. And if it is sustained, then we may want to see what would happen if we were to increase the pressure beyond 80 to see whether or not the same relationship holds true. So that brings us to the end of today's lecture.